Hello students. Student, in the previous lecture just we have to finish the theory part of the inverse trigonometric functions. Basically in that part we have to see the some properties related to the inverse trigonometric functions, as well as there are some situations and some conditions are also to be given for inverse trigonometric function, because inverse of any trigonometric function is to be possible only for the restricted domain. That's why we have to just discuss the sum of conditions also related to the given properties. But according to the NCERT, if we have to just ignore that part, then definitely in the NCERT questions I think there should be no problem is to be there, and as per the board level you can just direct use the particular formula, you can say that, or particular property directly is to be used to solve the various type of question. Is that to be clear? Today student, we are going to start the exercise related to the properties of inverse trigonometric functions, that is exercise 2.2. we will see each and every question carefully, and you have to just check your solution if you have to already done, and suppose any of the student is not done the questions, then definitely learn each and everything related to the given property, what should be given and how the particular things are to be get simplified. Is it to be clear? So we will start the very first question of this exercise 2.2. In the very first question you can see here prove the following. In this exercise 2.2, the very first question you can say here, prove the following: 3 sin inverse x equals to sin inverse of 3x minus 4x cube, where this particular x is to be given from minus 1 by 2 to plus 1 by 2, closed interval. So basically in basic when property we have to already discuss in the theory part, but suppose any question is to be coming in your examination, then how the particular solution of that type of question is to be get written, we can check this thing. So we will take this question. So here in this very first question, just we have to prove that a very common identity and common property already we have to discuss, like 3 sin inverse x will become sin inverse of 3x minus 4x cube, where this particular x belongs to minus 1 by 2 to plus 1 by 2. It should be given. Now student, one strategy we will just use to prove that type of identity. Directly you can just derive this whole identity, no problem, but here just we have to prove this thing, then we can use the trigonometric substitutions. And for this part, definitely student, the trigonometric formula already we have to discuss in the various kind of properties are to be very important for us. So we have to just take one of the side and we will use just trigonometric substitution, and which type of trigonometric substitution is to be suitable for the given expression, it will depend on the particular formula and a given expression. According to the given expression, we have to use the suitable trigonometric function, so that this particular whole part will become a particular kind of formula. So here just we have to take the right hand side. In this case, right hand side will become written as sin inverse of 3x minus 4x cube. Now we can just put here easily, you can say that you can just take x equals to sin theta, because each and every student know very well about the formula of sin 3 theta, because here you can check if x will be taken as sin theta, then it will become 3 sin theta and it will become minus 4 sin cube theta, and I think this is the formula of sin 3 theta, you know very well. So we have to just see the expression according to that which formula is to be made. First of all we have to think this part, and according to we have to use the some substitution of trigonometric function. So now you can just write here, this is to be sin inverse of 3 sin theta minus 4 sin cube theta. You can just say that this is 4 sin cube theta. Now definitely this particular part will be written as sin of 3 theta, means now this particular part will become a formula of sin 3 theta. And we have to keep in mind such kind of formula, because in each and every question of this exercise definitely we will just simplify the things just by using the trigonometric substitutions. Now the condition is to be given, we have to just simplify this thing. Some of the student directly says that this will be cancelled out this, and answer will be 3 theta, and after that theta is to be taken from here sin inverse x, then you will just say that the answer will be 3 sin inverse x, and hence proved. But student, this is the incomplete solution. Why this condition is to be given? So we have to just check this condition also, and in examination definitely if we will check, then the proper answer is to be considered. So we have to take x from minus 1 by 2 to 1 by 2. Now what is x? We have to use here x as sin theta, so you can just write here sin theta. Sin theta will be taken from this part to this part, then theta, then you can just calculate the interval of theta, that is minus of pi by 6 to pi by 6, because the sin pi by 6 has the value 1 by 2 here. Now we have to just calculate the interval of 3 theta here, because here the 3 theta will be there, so we have to just do the multiply by 3, then it will become minus pi by 2 to 3 theta to plus pi by 2. Now you know very well the principal value of sin inverse will be minus pi by 2 to plus pi by 2. So definitely now in this case 3 theta will belongs to this interval, then you can directly now write the answer as 3 theta, and theta can be again from here written as sin inverse x, and that should be your left hand side. So in this way just we have to write down the answer. In such type of questions, whenever we have to prove the some property or anything else, then you can use the trigonometric substitutions, but trigonometric substitution should be proper so that it will become a formula. Otherwise, suppose you are just saying that we can just put here cos theta, tan theta, any other trigonometric function you can use, but we have to just convert this thing in a particular kind of formula that is to be suitable for the question. Is it to be clear? So student, such type of questions are to be generally asked in examination, then the solution strategy you can just follow like this always. Is it to be clear? Next question number 2 we will take, student. Before that, pause the video to note it down. Next question number 2, again the very similar kind of question is to be given. You can check here. This is written as 3 cos inverse x equals to cos inverse 4x cube minus 3x, and here the interval is to be given as 1 by 2 to 1. So again a very simple question is to be given. Just you have to take the question and simplify this in a very similar manner. So in this question just we have to prove that 3 cos inverse x should be written as cos inverse of 4x cube minus 3x, where this particular x should be written from 1 by 2 to 1. This is to be given. So again we have to take the right hand side. You can take either of the side, but here in the right hand side you can just see the expression, so where we can just put any trigonometric function so that this part will become converted into the particular type of formula. So we can say that it is to be written as cos inverse 4x cube minus 3x. Now definitely you can say that here you can use the x equals to cos theta, because 4 cos cube theta minus 3 cos theta, that should be the formula of cos 3 theta. So finally we can just put here, then it will become 4 cos cube theta minus 3 cos theta, and now you can say that this part will be written as cos of 3 theta. Now you can again check whether this cos inverse will get cancelled out with this 3 theta or not. So for this purpose just we have to simplify the given condition here. So this particular x is to be written from 1 by 2 to 1, then x is what here? Cos theta. Now the student, this particular function is cos theta, then cos is the decreasing function. Whenever we have to just calculate the theta from any decreasing function in such kind of inequality, then the sign of inequality will get changed. Is it to be clear? So the value 1 by 2 will be occur pi by 3, and this value will be 0. So you can say that this is 0 here, and here this theta, and here for this part we have to write the angle here, this is pi by 3, because just we have to change the inequality or we have to just interchange these values, then there should be no change in inequalities to be get considered. Either of the part you can just say. Is it to be clear? So corresponding theta for this half we have to write here, and for corresponding this one, the value of theta we will write here. So just you can say that the sign of inequality will get automatically changed. But in this case you can check here, this is the 3 theta. So 3 theta means we have to just multiply by 3, then 3 theta will belongs to 0 to pi, and I think each and every student know very well this particular cos inverse has the principal value from 0 to pi, and 0 to pi means this cos inverse and cos x will be written as x. So now you can say that this will be written as 3 theta, and theta is what? Again you can check, this is 3 cos inverse x, and now you can say that this is the left hand side, because already we have to take the right hand side to simplify this question, so we will obtain the left hand side as well. Is it to be clear? So both the questions are to be the very simple, but what type of strategy we have to just follow and we have to just use to simplify these type of questions, to prove these type of questions. That is the very important part for the inverse trigonometry, where we have to use the trigonometric substitution. Is that to be clear? Next question number 3, student, we will take. Before that, pause the video to note it down. Question number 3 we have to just take here. So let's see the question number 3 again. A very simple question where tan inverse of 2 by 11 plus tan inverse of 7 by 24, and that should be equals to tan inverse of half. Now you know very well about the basic property of tan inverse x plus tan inverse y. So a very simple question is to be there, where we have to check the condition x y less than 1. So definitely this is x 2 by 11 and y is 7 by 24. So xy will be 14 divided by 11 into 24. So though basically the denominator part is much more higher than the numerator, so the product of xy is always found to be the less than 1. So direct formula you can just apply here of tan inverse x plus tan inverse y as tan inverse x plus y upon 1 minus xy, and to apply this formula, and after the calculation you will get this result. So easily, student, this question you can just do here, no problem. So next question we have to take here, question number 3. In this question number 3, the left hand side, we have to take the left hand side as tan inverse of 2 by 11 plus tan inverse of 7 by 24. Now you know very well about this identity, tan inverse of x plus tan inverse of y. That should be written like this, tan inverse of x plus y upon 1 minus xy, and in this situation we are saying that this xy is always found to be the less than 1. So basically here just we have to use the identity to simplify the things. Then definitely tan inverse x plus y, so this is taken as x and this is taken as y. So this is 2 by 11 plus 7 by 24 divided by 1 minus xy, 2 by 11 into 7 by 24. Is it to be clear? Now we will just do the sum simplification just after taking the LCM. So LCM of this numerator and denominator, both the part will be same, so they will that will be cancelled out. But before that, this part is to be get multiplied, then 48. This part is to be get multiplied, then it is 77. Next, this 11 into 24 you can just find, and this is to be get multiplied with 1. So you can just calculate the multiply of 11 and 24. So 11 4 is 44, this is 20 and 26, 264. You can just check the calculation here. So this part will be written like this, 264 minus 14. Now the LCM of denominator and numerator both will be same, so this will be cancelled out here. Now you can just simplify the part, add both the part here, then add plus 7, this is 15, here this is 12, and here 264 minus 14, so this will be 250, and easy calculation you can just check here. 125 is to get cancelled out with this part, then 250, so finally you will get the answer as tan inverse of 1 by 2, and this is I think your right hand side. Is it to be clear? So a very common and basic question is to be there, where we have to use this particular property. Already we have to see in the theory part. Student, we have to just know each and everything so that easily you can just do the calculation for the related property. Is it to be clear? Next, question number 4 we will take, student. Before that, pause the video to note it down. Question number 4 we have to take here. In this question number 4, again you can check the question. This is 2 tan inverse of half plus tan inverse 1 by 7 equals to tan inverse of 31 upon 17. No problem. A very basic, again the similar kind of question, but something is to be changed here, because here 2 tan inverse half. So definitely we have to know about the formula of 2 tan inverse x first of all. After that we will apply the tan inverse x plus tan inverse y to get the required result. So 2 tan inverse half plus tan inverse 1 by 7. So the question number 4, we have to take the left hand side as 2 tan inverse of half plus tan inverse of 1 by 7. So first of all, just we will write properly here, tan inverse of 1 by 7. So first of all, we know very well about the formula of 2 tan inverse x. That should be tan inverse of 2x upon 1 minus x square. So definitely you can just apply the formula in this section. This formula is to be get applied in this section. Then definitely you can write here tan inverse of 2x. X is what? 1 by 2 upon 1 minus x square, that is 1 by 4. And this tan inverse of 1 by 7 we will write as it is here. No change is to be there in this particular part, tan inverse 1 by 7. So here just this will be get cancel out. Here you can just simplify the thing, then it should be 1 and it should be 1 minus 1 by 4, that is 3 by 4. So finally we can write this part as 4 by 3 because this 4 will go in the numerator part. Next we can just write here tan inverse of 1 by 7. Now you can use the again similar kind of property, that is tan inverse of x plus tan inverse of y. That should be written as tan inverse of x plus y divided by 1 minus xy. So student, here in the each and every type of questions just we have to see the basic expression. According to that we have to just use the property so that easily you can get the required result. So now you can just take this part as x and this part as y, and definitely xy is already found to be less than 1 because 4 by 3 multiplied by 1 by 7, that should be 4 by 21. So definitely it should be less than xy less than 1, no problem. So finally we have to apply this property then. Tan inverse x plus y, so 4 by 3 plus 1 by 7 upon 1 minus xy, so this is 4 by 21. Is it to be clear? Now you can just simplify the part. Then 4 by 3 plus 1 by 7, so this is to be get multiplied, then 28 plus 3 divided by this is 21 minus 4. Just you can just simplify yourself because this is the calculation part. Here there's some addition subtraction of the fractional number is to be there, so easily you can do this calculation by yourself. Not you have to just understand the thing because this is not the concept here. Concept is that this what we are using here and how the particular answer is to be get obtained. So this 28 plus 3 will become 31 divided by this will be equals to 17, and I think this should be equals to the your right hand side. So easily you can do the question in a very systematic way, but before that we have to just know about the each and every identity. This should be the very important thing for us. Is it to be clear? Next question number 5 student we will take. Before that pause the video to note it down the answer. So that next question number 5 we have to take here. In this question number 5 you can just check. First of all, this question number 5 says that write the following function in the simplest form. Again the question will become the will be a form of the simplest form. So definitely student, when we have to write the simplest form, then any input that should be of complex type of input is to be there. Sometime the expression in form of x is to be get written, sometime the some trigonometric functions are to be given. Then we have to just simplify the given input part so that the basic whole inverse will be get simplified here, and as per the given condition we have to just simplify the part. So in this case question number 5, 6, 7, 8 you can just see the expression where you can check this particular input is the complex type of input. When we have to use this particular input in any of the property, then the calculation will be very bigger. So how we will just simplify this part in a very simplest form? So for that we have to again say that we are using the trigonometric substitutions. Is it to be clear? So these questions are to be again based on the trigonometric substitutions. Is it to be clear? So we will take the question number 5. Tan inverse root of 1 plus x square minus 1 upon x. So we have to just take this question. Question number 5. In this question number 5 it is to be given as tan inverse of under root of 1 plus x square minus 1 divided by x, and here it is to be written as x not equal to 0 because somewhere x should be in the divide part and where this should not be defined sometime, that's why it is the given. But before that we have to just see the expression carefully. Student, here again we have to use the some trigonometric substitution. Trigonometric substitution will be in such a way that we have to just simplify the square root and anything else that should be written here. So 1 plus x square. So I think each and every student know very well about this identity. 1 plus tan square theta will become sec square theta. So if we are knowing about this part, then definitely on behalf of this part, this is 1 plus x square. So you can just take this particular x as tan theta. So this part will become 1 plus tan square theta, and 1 plus tan square theta will become sec square theta. and square root is to be also get eliminated here. So our priority is to be get the simplified the expression. That's why we have to use the some suitable trigonometric substitution here. And for this part, again I am saying the formulas, identities are to be the very important for us. Next, so in this part again we can say that we have to put the x equals to tan theta. Now we will put x equals to tan theta, then the given expression will become like this: 1 plus tan square theta minus 1 divided by tan theta. And now as per this rule you can say that this 1 plus tan square theta will become sec square theta. Square root is also to be there, so this part, whole part will become the sec theta now. So finally we will write this expression, then tan inverse, this is sec theta minus 1 divided by tan theta. Now at last we have to just eliminate the square root, then we have to change the sec, tan, each and everything in the sine or cos. So definitely sec theta will be written as 1 upon cos theta, and this tan theta will be written as sine upon cos theta. So after just simplifying the part, we can just write here 1 upon cos theta, and after taking the LCM it will become 1 minus cos theta divided by sine theta. So now the expression will become like this. Now the next part we can check here. So 1 minus cos theta, so I think you know very well about the 1 minus cos theta. 1 minus cos theta will be written as 2 sine square theta by 2. And basically this sine 2 theta, sine theta formula you can write like this: 2 sine theta by 2 cos theta by 2, because you know very well about the formula of 1 minus cos 2 theta and 1 plus cos 2 theta as well as sine 2 theta. These formulas are to be the very important. Here you can check the part which are to be used to solve the questions. So definitely student, if you are not knowing the formula, then again I am saying, because in whole mathematics of class 12 the trigonometry will be very helpful for us. So here just we have to know about each and every kind of formula related to the trigonometry. So 1 minus cos theta, just you can use here, that should be 2 sine square theta by 2, and divided by this sine theta can be written as 2 sine theta by 2 and cos theta by 2. Now this 2 will get cancelled out, one sine is also to be get cancelled out. Finally the given expression will become tan inverse of tan theta by 2. Is it to be clear? Because this sine theta by 2 divided by cos theta by 2 can be written as tan theta by 2. Now the part tan inverse here, tan, then it will be get cancelled out or not. So definitely we can say that tan x is not equal to 0, it is to be given here. So x is what, tan theta, tan theta not equals to 0 means tan theta has the some value that should be greater than or less than. Is it to be clear? So whenever we have to take the interval of the principal value of tan inverse, then particular theta will become like from minus pi by 2 to plus pi by 2 open interval. So directly you can write down this expression as theta by 2, no problem. Now 1 by 2 is there, but theta is what? Theta is to be taken from here, that is tan inverse of x. So finally you can just write the simplest form of the given expression as 1 by 2 of tan inverse x. Means now this whole input part will get converted into the x. So such type of calculations are to be considerable as the simplest form of the given ITF inverse trigonometric function. Is it to be clear? So in such type of questions the basic thing is to be required the trigonometric substitution. If we have to use the proper trigonometric substitution, then easily you can do the solution, otherwise you will face the some problems. Is it to be clear? Next question number 6 we will take, student. Before that, pause the video to note it down. Question number 6 is again the similar kind of question, where we have to say that tan inverse of 1 upon under root of x square minus 1, where modulus of x is greater than 1. No problem. This condition is to be held to get satisfaction of the principal value of tan inverse. So no problem is to be there. We have to just see the thing what should be given here, 1 upon under root of x square minus 1. Then what type of trigonometric function we have to use to simplify and to write the simplest part of this thing. So we will just take this question, question number 6 here. In this question number 6, it is to be given as tan inverse of 1 upon under the root square minus x square minus 1, modulus of x is greater than 1. No problem. Now student, you know very well about the basic part of cosec square theta. So and 1 plus cot square theta, you can say that 1 plus cos square theta, that should be written as 1 plus cot square theta will be written as cosec square theta. So you know very well about this identity. Cosec square theta will be taken as 1 plus cot square theta. So you can just think about this particular identity from the trigonometry section, where if this particular 1 is to be shifted here, then it should written like this: cosec square theta minus 1, that should be written as cot square theta. Now you can just see the expression inside the square root as suppose if we are using x equals to cosec theta, then cosec square theta minus 1, so that should be written as cot square theta, and under the square root cot square theta, then it will become cot theta, and 1 upon cot theta will be written as tan theta, and outside function will be tan inverse. So there should be no problem. So we have to just put x equals to cosec theta. Now some of the students says that, sir, how we will think about this part, which type of function is to be used when. So student, for this part again I am saying that trigonometric expressions, trigonometric formulas, identities are to be very important for us, and when you will do the practice, then definitely automatically these things are to be coming in your mind. Otherwise, just if you have to think only and you are not using that part, then definitely some problems is to be there. Is it to be clear? So we have to just use these things, and you can just substitute many more parts. Then you can say that you will find that some of the times the expression will get simplified, but some of the time the expression will not be simplified. Then when we have to do the practice more and more, then this type of process will be coming in your mind directly. Is it to be clear? So tan inverse 1 upon square root of cosec square theta minus 1 you can write. So this part will become 1 upon cot theta now, because cosec square theta minus 1 you can say here cot square theta, and cot square theta under the square root, then it will become cot theta. Now 1 upon cot theta. So the 1 upon cot theta will become tan theta, and you can just say that tan inverse of tan theta will be now tan theta, because here modulus x is greater than 1. So definitely student, from this part you can say that x is either greater than 1 and x is less than minus 1. So we are using the cosec function here. So according to the condition we can use this condition, and you know very well about the particular domain and range of the cosec theta and cosec inverse also, because where we have to just see the inverse part of cosec, then the range domain part of cosec will be taken as x is greater than 1 or x is less than minus 1. Is it to be clear? So this should be satisfied with this cos theta also. Then I think there should be no problem to obtain this answer, because automatically it will be defined in the principal value of tan inverse. So now you can just write down the value of theta, then theta will be written as cosec inverse of x. Is it to be clear? So the simplest form of this whole part will be written like here, cosec inverse of x. So in such a way you can just attempt the question, and according to that we have to just give the answer of the questions. Is it to be clear? So the next question number 7 student we will take, but before that pause the video to note it down. Next question number 7 we are taking. Question number 7. Again in this question number 7, tan inverse of under the root 1 minus cos x upon 1 plus cos x. One important thing here, direct trigonometric function is to be already written. Now we have to use the particular formula only. Is it to be clear? No requirement to use any extra effort, means what type of substitution and what trigonometric function is to be get used where, because here in this question direct trigonometric function is to be appear in this input section. So there should be no requirement to write the particular trigonometric function or which trigonometric function is to be used to solve the given expression, because here directly the trigonometric function will appear in the input part. So we have to just concentrate on the formula, and where x should be written from 0 to pi, no problem is to be there. So we will just write this question number 7. In this question number 7 the expression should be written like this: tan inverse of under root 1 minus cos x divided by 1 plus cos x, where x is to be given from 0 to pi. No problem. Now student, you know very well about the two important formula, 1 plus cos x and 1 minus cos x. 1 plus cos x will become 2 cos square x by 2. 1 minus cos x will be written as 2 sin square x by 2. So we are using these two important formula in this section to simplify the part. So tan inverse, it should be written as 2 sin square x by 2 divided by 2 cos square x by 2. Now this 2 will get cancelled out, sin square upon cos square will be tan square. So finally the given part will be written as tan x by 2. And finally the given expression will be become tan x by 2, because square is to be there, then due to this square the square root will get cancelled out and sin upon cos will become the tan also. Now the condition is x from 0 to pi, here the x by 2 will be appear. So suppose 0 to pi x is there, then x by 2 is to be belonging to 0 to pi by 2, and you know very well about the principle of this tan inverse, that should be minus pi by 2 to pi by 2. So here this particular x by 2 lie in the principal value of tan inverse, so you can just write down this answer as x by 2, no problem. So finally you will get the simplest form here, direct simplest form you will obtain, because of the trigonometric function is already to be given s. Is it to be clear? So when we have to write the simplest form, then you can check student, these important section of the formula we are just using here, and without the using of this formula you cannot get the answer. So in whole calculus part we will use again the such kind of formula, so we have to keep in mind these things, and according to that we have to just process the given question. Is it to be clear? Next question number 8 student we will take, but before that you have to just pause the video to note it down. Next question number 8 you can check here. Again in this question number 8, tan inverse cos x minus sin x upon cos x plus sin x, and this x is to be given from minus pi by 4 to 3 pi by 4, no problem. So tan inverse of cos x minus sin x upon cos x plus sin x is it to be given, means direct trigonometric function is to be appear in the input part, so there should be no requirement to put the any trigonometric function in place of x. Is it to be clear? Only just we have to simplify this part to make this part into the form of tan, so that tan inverse will get cancelled out with the tan. So these type of theory we have to just apply here. So next question number 8 we will take here. This question number 8 we are taking. In this question number 8, it is to be written as tan inverse cos x minus sin x divided by cos x plus sin x, and here this particular x is to be given from minus pi by 4 to 3 pi by 4. This is also to be given here, no problem. Now the thing is, basically we have to just see the expression, how this particular expression will be will become in form of tan. So for this purpose just we are dividing by cos x numerator part as well as the denominator part, means suppose cos x is to be get common from here and cos x is to be get common from here, then we have to take the cos x as common, then it will become 1 minus tan x. Here in the denominator part cos x will be common, then you can say that it will be 1 plus tan x. You know very well, because cos x is common, then it will be 1, and here sin x upon cos x will be will become tan x. Now this cos will get cancelled out. Finally tan inverse of this will be 1 minus tan x divided by 1 plus tan x. Now a very important formula student we have to keep in mind always, tan of x plus y. So tan of x plus y is what? Tan x plus tan y upon 1 minus tan x multiply with tan y. So this formula now we are using here in to make this particular part into in this formula, this particular 1, so 1 can be written as tan pi by 4, because the tan 45 degree has the value 1. So this 1 can be written as tan pi by 4 minus tan x divided by this is 1 plus, here you can say that this tan x is to be multiplied with tan pi by 4, then there should be no problem, because tan pi by 4 is already said to be 1, so 1 is to be get multiplied with tan x, then already it should be a 10. Now this is the formula of tan x plus y, then similar formula tan x minus y you can write here, tan x minus tan y divided by 1 plus tan x multiply with tan y. Is it to be clear? Now now here you can just check with this formula of this expression. This is a and this is x and this is y. Then 10x minus 10y upon 1 plus 10x into 10y. So now this whole part will become like this 10x minus y. So you can write this inside part as 10 of pi by 4 minus x. This part can be written like this. Is it to be clear? Now it will depend on this particular angle whether this tan inverse will get cancelled out with this 10 or not. Is it to be clear? So for this part the condition is to be given, and the condition is to be given as pi by 4 minus x. So first of all we have to just do the multiply with the negative sign, then it should be pi by 4 greater than minus x, and here greater than, and here minus 3 pi by 4. Suppose we have to just do the multiplication with negative sign of any inequality, then the sign of inequality will get changed, you know very well. Is it to be clear? Now pi by 4 minus x, so pi by 4 is to be get added here, then this particular expression will become pi by 2 because pi by 4 plus pi by 4. Here we can write pi by 4 minus x, and here minus 3 pi by 4 plus pi by 4. So definitely it should be minus 2 pi by 4, and minus 2 pi by 4 can be written as minus pi by 2. So again you can just check this particular angle pi by 4 minus x. So this pi by 4 minus x you can check will lie from minus pi by 2 to plus pi by 2, and this is the principal value of this tan inverse also. So finally you can write down this result as pi by 4 minus x. So this will be the simplest form of the given inverse trigonometric function. So these conditions are to be very important, students. Just we have to simplify the things, and the most important part is the trigonometric formula and identity that we have already done in the property sections as well. In the class 11 already you have to just read the chapter of trigonometry. So from where you have to do the practice of learning these formula. These are the very important part for us. Is it to be clear? Next question number 9, student, we will take. Before that, pause the video to note it down. Question number 9 we are taking. So you can just check the question number 9. Again we have to write the simplest form of the given function. Then definitely here this question number 9 says tan inverse x upon under the square root of a square minus x square, where modulus of x is less than a is to be given. No problem. We can just use the some trigonometric function here, because no trigonometric function is to be already appear. So we have to use the some suitable trigonometric function to simplify the part. Is it to be clear? So we will take this question number 9, tan inverse x upon under the square root x a square minus x square. So next question number 9 is to be written like this: tan inverse x upon under the square root a square minus x square, and here modulus x is given as less than a. Is it to be clear? Means as per this condition you can say that this x is to be greater than minus a and less than a. So you can just elaborate this condition like in this way, minus a to a. Now we can just say that we can put x equals to a cos theta or a sin theta, no problem, because both the part will be very important here. Suppose we have to just put here x equals to a sin theta, then it will become a square sin square theta. A square will be common, then 1 minus sin square theta. So 1 minus sin square theta will become cos square theta. So definitely you will get able to simplify this part. Is it to be clear? So now this type of substitution we are using here, then this x will become a sin theta. Now under the square root a square minus a square sin square theta we can say. So now this a square will be taken as common. Outside of this square root it will become a, and from the numerator this a will be get cancelled out. Now this is 1 minus sin square theta. So 1 minus sin square theta will be taken as cos square theta, and under the square root of cos square theta will become cos theta now. So finally if we will just see this part, then it will be a sin theta, and the denominator part will become a cos theta. Is it to be clear? Now a will be get cancelled out, and again you can say that tan inverse of tan theta will be there. Now the theta is what? So basically we have to just see the condition. X equals to a sin theta, so minus a, here x is a sin theta, then it is a, divide by a, then it should be minus 1 sin theta, and this is plus 1, then theta is to be taken from minus pi by 2 to plus pi by 2, no problem. And this is the principal value of this tan always. Is it to be clear? So definitely the principal value of tan inverse is to be also from minus pi by 2 to plus pi by 2 open interval, and that should be satisfied for the given theta. So you can just write down this answer as theta. Now we have to just put the value of theta from the given substitution. So firstly we have to find the sin theta. So sin theta will become x upon a. Then theta is what? Sin inverse x upon a. So we can say that this theta can be written as sin inverse x upon a. So this will be the simplest form of the given expression here. Is it to be clear? So each and every question whenever is to be get written in the simplest form, then we will do the working like this always. Is it to be clear? Next question number 10 student we will take. Before that pause the video to note it down. Next question number 10 we are taking of this exercise 2.2. So in this question number 10 again tan inverse 3a square x minus x cube upon a cube minus 3a x square. So any given input is to be written in the complex form where a is said to be greater than 0 and this x will be minus a by root 3 2 plus a by root 3. No problem. Student, you know very well about the formula of tan 3 theta. So tan 3 theta is what? Tan 3 theta is basically 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So first of all we have to just think about this a, because this a will be get eliminated. So this x should be in terms of a we have to take, so that here a, then a square and a will be a cube, here x cube, then automatically a cube will be there. So finally from the numerator part a cube will be common. Similarly here a cube is directly appear and here x will be written in form of a, then 1a is already to be there, then here also a cube will become. So a cube will be get cancelled out. So first of all we have to see this thing, this a will get cancelled out. So x will be taken in form of a. Now a is a into what? Trigonometric function. So now you know very well about the formula of tan 3 theta, that is 3 tan theta. So here 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, because this is 1 by, because this a cube will get cancelled out. That's why we are saying this thing. So now you can just understand the given expression. First of all carefully you can see this thing, and according to that we will use the proper trigonometric functions. So the question number 10 we will take here. Question number 10. In this question number 10 the given expression can be written like this: tan inverse 3a square x minus x cube divided by a cube minus 3a x square. This is to be given, and here the condition is to be given as a is greater than 0 and minus a by root 3 2 plus a by root 3 the value of x is to be written. Now just you can put x equals to a tan theta. Why we are taking along with tan theta as a? Because just we have to get eliminate this a. That's why a is to be also to be taken, because a is any constant, that should be greater than 0. No problem. So definitely when we have to use this substitution, then this part will become tan inverse here 3a square into x is what? A tan theta, minus this will be a cube into tan cube theta, because x is what? A tan theta, divided by a cube. So this will be a cube minus 3a square x. So 3a into this part will become a square into tan square theta. Now you can check student, a cube is there, a cube is there, this is a cube, and a into a square will be a cube. So a cube will be cancelled out because it will be taken common from the numerator as well as from the denominator. So finally we can say that this part will become tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now you know very well about this particular formula. They are very standard formula student. Already just we have to read the property, then this formula is to be get discussed where also, and you have to keep in mind always the this type of formula. So now this particular formula will be written as tan 3 theta. Now tan inverse and here tan 3 theta. So before knowing the interval of 3 theta, we cannot say this part will become the 3 theta. This will become 3 theta when this 3 theta is to be lie from minus pi by 2 to plus pi by 2. This is the principal value of the given inverse. So for this part we will just simplify the condition, and here x is what? Here you can check, x will be taken as a tan theta, and this is a by root 3. Now this a is to be get divided by whole inequality because a positive number is to be there, so no sign of inequality will get changes here. So minus 1 by root 3 to plus 1 by root 3, we will take the interval of tan theta. Now the theta is what? Basically 1 by root 3 value of this theta will become at minus pi by 6 and this value is plus pi by 6. Now this particular inequality is to be get multiplied with the 3, then you can say that 3 theta, so 3 theta will be lie in this interval minus pi by 2 to plus pi by 2. Is it to be clear? So that you can just check this 3 theta will lie in this interval, or this is the principle of this, so that you can write down this part as 3 theta and this theta. So theta you can just calculate from this section, that is tan inverse x upon a. So you can write this part as x upon a. Is it to be clear? So definitely student, in each and every cases of simplest form, just we have to use the some trigonometric formula, as well we have to just simplify the condition also, because the condition always very proper conditions are to be given, which is to be get simplified, then definitely the principle of the given inverse trigonometric function will get satisfied here always. And in each and every question of this NCERT you can check here, no particular mistake is to be obtained in the case of principle. That's why I am saying only the standard formula you have to just apply, then directly you will get the answer in examination also. Is it to be clear? So student, in this video just we have to discuss the up to question number 10 of the particular NCERT exercise 2.2, but the remaining of the questions we will just simplify in the later on next video, where again I am saying you have to do the practice. Definitely you will get the answer of each and every question, because we have to see the each and every property carefully. And here one more important part of the trigonometric substitutions as well as the trigonometric formulas. So you have to make the list of each and every trigonometric formula, and just day by day you have to learn. Then definitely in entire calculus, not in this chapter, in entire calculus we are using that formula, so that the formula will be get clarified to you. Then obviously the questions and calculation will be very simplified for us. Is it to be clear? So each and every student make the list of formula of trigonometry from the class 11th, you can say that, because in class 11th all the formulas are to be found in the chapter number 3, from where you can make the list and you can remember each and every formula, learn each and every formula just by making the practice, so that easily such type of calculations are to be very simplified to you. Otherwise you will face the some problem in the calculation part. Is it to be clear? So in next video student, we will meet with the some remaining question of this NCERT exercise 2.2. but before that I want to say that these questions are to be the very important. Such type of questions are to be generally asked in examination, so you have to just do the practice of these questions, so that in examination you have to just know problem is to be facing by you. And in entire calculus, in the differentiation cases, again such type of questions are to be there. Then firstly we have to make the simplest form, and after that we will do the differentiation. So these things are to be again very important for the further chapters also. So thank you student, we will meet with the some remaining question in the next video. Thank you.